Okay, this was another example from Khan Academy with an ellipse, and the cross sections were semicircles. So from the diagram here, you realize that we're perpendicular to the y-axis. So we want to solve for x, or actually x squared. We want to get everything in terms of y. So you know your radius is going to be x in this case, and we're going to be finding 1/2 pi r squared. But instead of radius squared, we do x squared. So we need to change that area formula into something with y. So you take your ellipse equation and you want to solve for x in terms of y. Actually, I didn't go all the way to x because we just needed x squared. So after we divide everything by 4, we can plug in the 9 minus 9/4 y squared in for x squared. Now everything's in terms of y. We can simplify it a little bit. You don't have to pull the 9 pi over 8 out, but I did just to make it a little bit nicer numbers. The 4 minus y squared is much nicer without the fractions in there. So then we can write our integral. I pulled the constant out in front, and we're going from -2 to 2 along the y-axis. And if you were to take your time and evaluate that integral, you would get 0. And made a little note over here. This will give you 0. But it's an even function, right? So we can cut the interval in half and multiply it by 2. So if we integrate from 0 to 2, we'll just multiply that integral by 2, and then we'll have the full volume. And then you take the antiderivative, which gives you 4y minus y cubed over 3. And we're evaluating that from 0 to 2. And when you plug in 2, you get 8 minus 8/3. And the other one is, when we plug in 0, you get 0, obviously. And the rest is just simplifying. I'm sure you'll pause this video as you need to. Excuse me. And it actually works out really nicely to a perfect 12 pi. All right, keep up the good work. I hope that helps.